Welcome back everyone. In this lesson, we are going to be creating our player controller. Okay, this is basically going to be the scene that allows us to have a player that we can move around in our 3D world. Now, to begin, we need to create our player's base node, and this is going to be of type character body 3D. So I'm going to create a brand new node in our level 1 scene of type character body 3D and click create. Now, the character body 3D node is really great as it comes with a lot of stuff built in for creating player characters, okay? It has the ability to have physics applied, such as velocity. It can detect the ground, so it can then tell us if we're standing on the ground or not, and it can walk up slopes and detect ceilings, all some really cool stuff for having a character that you want to jump around in a physical environment. So I'm going to rename this node to be player. And then what we're going to do is we are going to drag in our player model. So we can go to our models folder, go down to where we have our character, drag them into the scene here, and then make them a child of player. I'm going to rename this node to be model, just so we can easily see what all these different nodes are called. Now, with this player here, what we can then do is we can actually resize this model a bit because we might want it to be a bit bigger. So I'm going to select our model, go to transform, scale, and I'm going to make this model 1.5 on all axes, okay? So they're a bit bigger than normal. Now what we can do is make sure that their position is set to 0 on the X, 0 on the Y, and 0 on the Z, so that they are nice and centered on our player model, okay? And at the origin location of this player node, that should be down at the feet of the model, okay? So there we go. Now what we need is a collision shape for our player so that they can collide with stuff. So we'll create a child node of player, make a collision shape 3D, capsule shape 3D. Now in games, generally players and any other humanoid thing that you want to move around a scene will use a capsule as their collider for two reasons. First of all, it's roughly shaped like a person, and second of all, it has a smooth head and it has a smooth bottom. Now, the reason why you want that is because if you're walking around on slopes and on little edges that might clip your feet, you want the player to be able to smoothly navigate around that. Now, if you had a box, you would have sharp edges at the bottom, which could easily catch on, a set of stairs, for example. Whereas a capsule shape has a nice smooth bottom that can slide and glide along these surfaces. So what we're going to do is we're going to get into a little side view here, and we are going to adjust the shape of this collider. So I'm going to move it up here a bit, decrease that radius there, decrease the height, and in fact, let's be a bit precise actually, and I'm going to open up the capsule shape 3D right here by clicking on it. I'm going to set the radius to be we'll say 0.4, oh no, that's way too large, 0.3. We'll set the height to be 1.2, and we'll move this collider up just a little bit so that we can just see the base of the capsule just peeking up here at their feet. And I think that should be it for our player, okay? And finally, we need one more thing, and that is going to be a camera. So the camera, we can right click on player, add child node, camera 3D, create that here. Now this camera is going to be sort of out a bit, so whoops, we're just going to move this over here. We can then rotate it down a tiny bit so it's looking down at the player. And we can also adjust this later on if we need, but I'm just going to keep it there for now. Inside of the inspector, we want to go down and enable current so that this camera is the one that is rendering. So we can save this, we can then press play, and it's going to ask us to select the scene, which we want to set as the default scene. We'll just go select current, and we should then see, once it loads, there we go, here is our player. Now our player is pretty far away, so what we can do to fix that is we can select our camera and we can adjust our field of view. Now I'm going to bring our field of view down to about 60, I reckon. Press play again, and we should see that we have a much better, more narrow angle on our player. Now, something else that isn't necessary for the player, but I think might be easier on your eyes, is setting up some sort of lighting, because right now our player is pretty dark. So what we're going to do is we are going to create a new node here of type directional light 3D. And this is going to basically add in the sun. We probably don't want the angle down here as if it's a sunrise, so I'm going to press E to go to the rotate tool and rotate the sun to a nice position, something like this right here, okay? So yeah, if you're making a game, try and set up the lighting so that the light is sort of hitting your character here, okay? You don't want the character to sort of be in shadow like this, as that doesn't really look too well, unless of course you're going for that sort of mood. So we then probably want some shadows as well, so I'm going to go to the inspector, open up the shadow drop down and enable shadows, just like that. Press play, and here we go. It looks much better. So now what we can do is start setting up our actual player script, which is going to control the player's movement and their jumping. Now to do this, we are going to select our player object right here. We're going to go to the inspector, go down to where we have script, and we're going to create a new script. We're going to call it player. And it's very important that this script does inherit from the character body 3D node. This should be set up automatically right here if you are creating the script on the character body 3D player node right here. But if for some reason that's not working, try it again, or you can just click on this button right here to choose the node you want to inherit from. And the reason why we need to inherit from character body 3D is of course because we are going to be accessing a lot of that functionality with movement and collision detection. So we can then click create, and that is going to open up this script right here, which as you can see has quite a bit of stuff already made for us. Now we don't really want to use any of this code, so I'm going to go ahead, select all of it and delete it, okay? Because we are going to be pretty much coding this from scratch, just so we have an understanding of what we are actually doing here. So all I want you to have is the extends character body 3D line of code here, and that is it. So in the next lesson, we are going to begin scripting our player, getting them moving and jumping. So thanks for watching, and I'll see you all then in the next lesson. Welcome back everyone. In this lesson, we are going to begin scripting our player controller. But before we do that, what we need to do is we need to actually set up our inputs, because this is going to allow us to easily detect which keys we are pressing, and we can pretty much define them beforehand. So to do this, we're going to go up to Project, Project Settings, and inside of Project Settings, we are going to go over to where we have Input Map. Now, Input Map allows us to create inputs, such as movement, jumping, and any other sort of buttons that you want to be able to detect. And what we're going to do is we are going to go down to Add New Action, and we are going to basically go move _ forward. Okay, click Add. That's going to create a new action down here, and what we can then do is assign a key press to that action. So we can click on the little plus next to the action here, add event, and this we are going to press W. And as you can see, it is going to basically search through a list here. There we go, we have W, click OK, and that, as you can see here, W physical. So this basically means that whenever we are listening to the move forward action, it is going to basically trigger whenever we are pressing the W key. And this is how we're going to set up all of our movement keys. So then we can add move _ backward, add that, click on the plus, press S to move backwards. There we go. And there we go. Okay, so what I want you to do now is go ahead and set up the left moving, the right move, as well as jump with the space bar. So have a go at that, and I'll be right back to see how you're done. Okay, so here we go. We, of course, have move forward, move backward, move left, move right, and jump, all with an action assigned, an event, assigned to them. So we can then close out of our project settings here, go back to our player script, and begin setting that up. So first of all, we need to create our variables. Now, first variable is going to be move speed. This is going to be of type float, and let's set this to be equal to 4. This basically means we are going to be moving 4 meters per second. We then want to have another variable for our jump force, and this is going to be the amount of force we are applying upwards whenever we jump, and this is going to be equal to 8. And then we need a way of actually pulling ourselves back down to the ground with gravity, so I'm going to create a variable called gravity. This is going to be of type float, and we'll make that 20, okay? And this is going to be the force that is going to pull our player back down to the ground. Now, another one is going to be a variable called facing angle of type float. We're not going to give it a value because this is going to be set pretty much every frame. And facing angle is basically going to be the angle in terms of degrees to where our player is facing. And we need this in order to basically set our model's angle, because we're going to have our 3D model rotate to face its moving direction. And we are then going to have our model as a variable right here. So we'll go variable model. This is going to be of type mesh instance 3D. And this is going to be equal to get underscore node. And we want to get the model right here. Now, in order for this line of code to work, we need to add the @onReady keyword right here. So basically, when this node is initialized, this function right here is going to be called. So we are going to find that model node right here, and we are going to assign it to this model variable. Okay. Now what we need to do is actually start moving our player around. So how are we going to do this? Well, first of all, we're going to create a function, and we are going to create the underscore physics process function. Now, the physics process function is very similar to the normal process function, in which that it gets called every single frame, but physics process gets called at a consistent time rate per second. And this means it is good for physics, which likes consistency, okay? So inside of this function, we are going to be detecting our movement inputs. Now to do this, I'm going to create a variable called input, and this is going to be equal to input.get_vector. Now this input get vector is a very handy function because it can take in a number of different inputs, well, 4 inputs, and give us a movement direction. So you can see here, we need to give it a negative x, a positive x, a negative z, and a positive z. And this is going to basically convert those inputs into a direction vector, which we can then apply to our player. So what I'm going to do is I am basically going to set the first one here in brackets. And as you can see, we have a list of all of our different inputs that we just created. So the first one is going to be move underscore left. We're going to go comma. We're then going to go move underscore right, comma. We are then going to go move underscore forward, comma, and then finally move underscore backward. And there we go. So we have left, right, forward, and back, and that is going to basically create a brand new vector variable, which we can then assign to our player's move direction. And for the direction, I'm going to create a variable here called dir, short for direction, and this is going to be equal to a vector 3, and this vector 3, we can assign an x, y, and z value to it. So the x is, of course, going to be the x of our input, so input.x. The y is going to be 0, since we don't want our player to be moving along the y of the keyboard. That's going to be managed by gravity and jumping. And then for the z, we aren't going to go input.z. The reason why is because this input vector right here is a vector 2, okay? It has an x and a y. The x is keeping track of our left and right inputs, and the y value is keeping track of our forwards and back movement inputs. So for this, we're going to go input.y, okay? And that should then convert this 2D vector into a 3D one, which correlates to our player moving in the real world. Then down into a new line, we can go velocity equals direction, okay? And this is basically taking this direction vector and assigning that to our character body 3D's velocity variable. Now this variable, we haven't actually defined anywhere here, but rather this variable is created and used inside of the character body 3D, which we are extending from. So that is how we can access that. And then finally, we want to call the move and slide function in order to apply that velocity. So we can save that. We can then press play and see if it works. So I can use the arrow keys, and as you can see, here I am moving around. Now, this is still very basic movement, but it does work, but there are a few issues. The first one is that we aren't moving based on our move speed, and if we walk off the edge, our character doesn't really fall, okay? They kind of just sink down a little bit here, and we can still walk around on the ground. So there are a few things that we do need to fix, but we'll go by them one at a time. Now, as a bit of a challenge between now and the next lesson, I want you to attempt to make it so that when we press play and we move around, that we move at a rate of our move speed. Because right now, we are moving basically 1 unit per second, but we have a variable here called move speed, which is set to 4. So what I want you to do is make it so that when we move around, we are moving at whatever our direction is by our move speed. Okay, have a go at that, and I'll be right back to see how you're done. Welcome back, everyone. So the first problem we need to solve with this script right here is setting it up so that our player can move at the rate of their move speed. Because right now, when we are getting direction, this is only getting a direction variable, which has a length of around 1. Okay, so we're only moving at around 1 meter per second. So how do we make it so that we move at 4 meters per second? Well, we're going to go down here to where we are assigning our velocity, and we are going to multiply the direction variable by move speed. So we're just going to go multiplied by move speed, like so. We can then save that, press play again, and see if that works. And as you can see, we are now moving around a lot faster at 4 meters per second. Now, there's also something else, and that is the fact that our model isn't rotating, okay? They're kind of just standing on the spot and just sliding around backwards, left and right. So we want to have our 3D model pretty much rotate to face whatever direction we are moving in. So to do this, what we can do is we can go down after we move and slide, and we want to check to see if our input is, first of all, greater than 0. And what we're going to do is we're going to go facing underscore angle equals vector 2. Now, what we have to do here is we base vector 2 of a capital V. We want to go input dot y, then input dot x, and then we want to go dot angle, okay? Now, the reason why we have to do this way, by putting the y in the x and the x in the y, is in order to get the y axis angle, okay? And then we go dot angle, which basically gets this vector and converts that to an angle, all right? So we're getting a direction with the input right here, and then we are converting that to an angle in terms of degrees. So now that we have our facing angle, what we can then do is we can then go model dot rotation dot y. Okay, we are modifying the y rotation because we want to rotate it so it's looking, around a pivot point. Then we want to go equals facing underscore angle. Okay, so we can save that. We can press play, and it will work, but there are going to be a few issues. And you can see if I move to the left, you can see it's all working just fine. But if I let go, we sort of snap back to facing forward. So if I move forward, you can see the character sort of snaps back to the camera, okay? And it's also pretty harsh, okay? There's no sort of smooth rotation between it. So we need to fix those 2 issues. Now, the first one is making it so that the character doesn't sort of flip back to face the camera whenever we stop moving. And the reason why that's happening is because we are always setting our facing angle even if we're not pressing anything. And if we aren't pressing anything, then that means that the input is going to be 0 on the Y, 0 on the X, and if we convert that direction to an angle, that is basically going to face us back to our default 0 rotation, okay? Because if we go into our 3D view here, and we select our model, go to the transform, you can see if we go to Y on the rotation is 0, it is facing the camera, okay? So if everything is 0, then we are sort of resetting to this default rotation. So we need to make it then so that we are only setting our facing angle if we are moving, okay? If we have a button pressed, that is the only time we are going to be setting our facing angle. Now to do this, we can just put this line of code here inside of an if statement, and that is going to be if our input dot length is greater than 0, then we set our facing angle. So what we're doing here is we are getting our input vector, we are getting the length of that vector, okay, or the magnitude, and this basically means if you sort of map this out on a graph, how long would that vector be? So generally, it's going to be 1 for a direction vector like so. So if that's greater than 0, then we are setting our facing angle. So now if we press play, we should see that if we can move around and stop, as you can see, our player isn't resetting back to 0, which is great. Now, finally, all we need is the ability to make our player sort of smoothly rotate between these rotations because it's pretty harsh at the moment. So to do this, we're going to go down to where we have our, where we're setting our model's rotation, and instead of setting it directly to facing angle, we're instead going to set it to be lerp underscore angle, okay? Now, lerp underscore angle, this takes in 3 values. It takes in a from, a to, and a delta, okay, or an amount. Now, from is basically what we want to rotate from, which is going to be our model.rotation.y. Our to is going to be to our facing angle. And finally, the weight is going to be sort of the amount or the speed that we want to move towards this facing angle. And for this, I'm going to set it to be 0.5 for now, although we might change that in the future. So I'm going to press play, and if I move around, you can see that what's happening is our player is sort of smoothly rotating between these different facing angles, okay? Instead of having that rigid snap, they are now lerping between those 2 angles, okay? Which is very nice. So yeah, lerp angle is very good for if you want a smooth transition between one angle and another. And you can, of course, modify the weight parameter at the back here. If you want to have it smoother, you can decrease that, or if you want it to be more harsh, you can move that up closer to 1. Okay? So that is the basis of our character movement right here. Now, all we need to do is set up the ability to jump. So, when it comes to jumping, we first of all need to make our player fall down. Okay, I think that should be the first step, because right now, if we press play, you'll see that our player just walks off the edge, and they're just kind of chilling out here. So what we need to do is we need to go to our physics process function, and right at the top, we need to go if not is underscore on floor, okay? Now this is on floor function is built into our character body 3D, and that is basically true or false for whether or not our player is standing on the ground. So if our player is not standing on the floor, then we want to pull them down. And to do that, we're going to go velocity.y minus equals, and then that's going to be gravity, okay, multiplied by delta. So we can save that, press play, and now if we walk off the edge, still not working. And the reason why is because down here where we are setting our velocity, we are setting our velocity to be equal direction multiplied by move speed. Now that seems fairly normal, but what we are also doing, as you can see, if we go to our direction variable, you can see that the y is 0. So basically, every frame we are setting our velocity to be 0 on the y, overriding the gravity right here. So what we need to do is we need to go down to where we have our velocity right here, and instead of assigning it directly like this, we are instead going to manually assign each axis. So we're going to go velocity.x equals direction.x multiplied by move speed. We then have velocity.z equals direction.z times move speed. Okay, and what we're doing here is we are basically skipping over assigning our y velocity, because we don't want the y velocity to be influenced in any way by our movement direction. Okay, we only want the y to be changed by gravity and by jumping. So now we can save that, press play, and we can still move around like normal along the x and the z axis, but if we fall off the edge, our player is then affected by gravity. Okay, so in the next lesson, we are going to be finishing off our player script, or finishing off the movement side of things, by setting up the ability for them to jump. So thanks for watching, and I'll see you all then in the next lesson. Welcome back, everyone. In this lesson, we are going to be setting up the ability to jump. Now, as you can see, I've gone ahead and actually added in a bunch of little comments right here. Now, a comment, we can just add in a hashtag or shift3, a pound sign, and that is going to turn this line of code gray. And this allows us to basically type in whatever we want, and it's basically a way of us adding in little notes to our code, okay? So once we start getting a lot of code like we have right here, it's good practice to add in comments so that when you come back to it later on, you can easily see what each thing done. And as you can see, I've added a line of code, I've added a comment to pretty much each line of code explaining what each individual thing we are doing here and how that's working. So feel free to add your own comments to your own code, as it can be a good way to sort of reinforce what you're doing by commenting down exactly what it is that you're doing. And maybe even before creating a function, you can add in multiple lines of comments, pretty much going step by step of what you're trying to accomplish. So let's get ourselves jumping. So after we apply gravity right here, we are going to go to a new line and we are going to create an if statement. Now this if statement is going to check two things. First of all, it's going to check to see if we are pressing the jump button, which is our spacebar, and it's also going to check to see if we are on the floor, okay? Because if we are up in the air, we don't want to be able to jump. So we'll go if input.is action pressed, okay? And that's going to be the jump action right here. And we can also combine two conditions together because this is action press returns true or false. We can then go and, okay, and that should turn red, is underscore on floor, okay? So this if statement is only going to run if these two conditions are true. So if we are pressing the jump button and if we are on the floor, then what we want to do is we want to basically set our y velocity. So we're going to go velocity.y equals jump force, okay? So we're setting our y velocity, so this is going to instantly shoot us up into the air. So we can save that, press play, and now we can move around like normal. We can then jump, and as you can see, it pretty much leaps us up into the air, and as we're in the air, our gravity is taking over and pulling us down, okay? Because once we jump into the air, we are no longer on the floor, so this gravity is then going to be applied, dragging us back down to the ground, allowing us to then jump again once we touch the ground. Now, one more thing I reckon we can do, and that is setting up the ability to basically reset our player whenever they fall off the edge. Because right now, we can have our player, we can jump around, but what if we accidentally miss the platform and fall down? Well, we're pretty much going to be falling forever at this rate, so instead what we need to do is have a function which can reset our player and reset the scene. So in our player script, we're going to go down here, we're going to create a brand new function, and this is going to be called game over. And this function is going to be called when a number of things happen. First of all, whenever our player falls off the level, this function is going to be called. Whenever we hit an enemy or a spike or anything that we want to basically trigger a game over state, that is when this function is going to be called. And what we're going to be doing in this function is we are first of all going to get the tree. So this is going to get the node tree of our current scene. And we then want to go dot reload current scene. So this is going to get our tree and it's going to basically reload whatever scene we are in. Okay, so if we are in level 1, it's going to reload level 1. If we are in level 10, it's going to reload level 10. So we can save that. We then need to check to see if our Y position is below a certain value. So inside of physics process, this can also be done in the normal process function if you wish, but I'm just going to do it in physics process just because we have everything already here. We are going to go to a new line here right at the bottom, and we are going to check to see if our global underscore position dot y is less than, and let's just say -5. Okay, so if our y is less than -5, then we are going to call game over. Okay, so if we fall off our level and our y position drops below -5, we are going to reload our current scene. So let's go back to 3D. And if you're not too sure on what you should set that value to, you can just select your player, open up their transform here in the inspector, and keep an eye on that Y position. So when our player falls below this right here, that is when we're going to reload our scene. You could make it a bit closer if you wish, but I'm just going to keep it to 5 for now. Let's press play, let's jump off the edge and see what happens. And there we go. Once we reach -5, our player is instantly snapped back to the top, and that is because we are reloading the scene. So all the collectibles and everything else you might have in your level will also reset at this point as well. So there we go. Now, in the next lesson, we are going to be looking at setting up some enemies, because right now our player can jump around platforms, but we want to have some ability to actually have our player get damaged and call that game over function. So between now and the next lesson, what I want you to do is I want you to go ahead and start creating some more platforms, okay? Because we only have one little one here for our player right now. So I want you to go ahead, create a number of different platforms here, move them around, adjust them in height, make sure that the player can actually reach them by moving and jumping, and you can change their positions. You can also change the player's move speed and jump force if you want to make it a bit bigger. But yeah, have a go at creating some platforms, and we'll be right back in the next lesson when we start creating our enemies.